Okay, so here we get in chapter 7 and 8. So chapter 7 is where we introduce energy balances. So here we have the equation for an open system energy balance where we're using enthalpy. And then we have here a closed system energy balance where we're using internal energy. And then we learned that when we use energy balances, we can make a few not assumptions. A lot of terms can cancel out based on what we know about the system or generalizations we can make about the system. So for internal energy, we can assume that internal energy is 0 when we have no temperature change or no chemical reaction or no phase change. And then heat, so Q, we can assume Q is 0 if we are told that the system is insulated. So it says it's well insulated, or if it says that it's adiabatic. And then work, so we can assume that work is 0 if we have no moving parts. And then delta EK, so change in kinetic energy. If the system's not accelerating, so no acceleration, then that is 0. Or so for delta EP, or change in potential energy, that is 0 if there's no height change. So the system isn't increasing in elevation. And then I think it was chapter 8 when we started getting into the steam tables. It might have been chapter 7. But here we have the different ways to calculate delta H, so specific enthalpy, specific internal energy here, based on whether you are dealing with an open system or a closed system. And so here are the equations for that. And the CP values, we practiced calculating those based on the what we find in the appendix. So CP is different for each specific component. And we did a lot of practice with that in some of the later SI sessions. I want to say like probably like session 10 has a lot of practice in this, or session 9. And then we have here a hypothetical path, which we know that we have to a lot of times create in order to mimic the true path. So in order to calculate the actual delta H, so the actual change in enthalpy here, we have to create these different steps based on the information we have, because we can't directly calculate the change in enthalpy from a solid to a vapor with a temperature and a pressure change. So you have to change like one thing at a time, calculate that specific enthalpy, and then your delta H would just be the sum of these different specific enthalpies. So 1 through 6 equals your total delta H here.